Okay, here's our first example. When the angle of elevation to the sun is 52 degrees, a tree casts a shadow that's 9 meters long. So here is our tree. And let's say here is the sun. Here. So the wording of this problem is a little off, but basically the angle of elevation to the sun is 52 degrees. So like the sun is up above the ground. So our horizontal line is going to be the ground, and our line of sight is going from the ground up to the sun. So this is an angle of elevation. It's 52 degrees. Remember, I need two things to form an angle of elevation. I need a line of sight that's going to something above, and I need a horizontal line. I have both of those things. Okay. Here's our tree, and when the sun is behind you, your shadow is going to be out on the ground in front of you. So here's the shadow. This is the shadow right here, this side. It is 9 meters long, and we are trying to determine the height of the tree. So I'm going to call that X. We are trying to figure out how tall the tree is. Okay, I'm going to think about if this is my angle theta, is X opposite, adjacent, or hypotenuse? It's the opposite side. And 9 is the adjacent side. So, if I'm thinking about SOHCAHTOA, which of my three trig functions relates opposite to adjacent? It's tangent, opposite, and adjacent. I'm going to use tangent because I am looking for the opposite side and I am given the adjacent side, so I'm going to use tangent. So tangent of, I put the angle in the parentheses, tangent of 52 degrees is equal to opposite, which is X, over adjacent, 9. I want to solve for X, so I got to get rid of this 9 that's in the denominator. So I'm going to multiply both sides of my equation by 9. And making sure my calculator's in degree mode, or else I'm going to get some really weird answers. 9 times tangent of 52 is 11.5, rounded to the nearest tenth. So 11.5. And these units are meters. So the tree is 11.5 meters tall.